All right, hello chemistry. We are working on a reaction puzzle today. It's also what we call the activity Karma Chameleon, right? So we're going to be assigning you this one. There are going to be some questions like this on the test, and it's best if you've got a little example to work from. So I'm going to show you one that's not on that Karma Chameleon assignment, but that is something that should be fairly straightforward to work through by the same process. So let's read the problem we're going to work on. We've got two colorless gases. They've been mixed. When a spark is provided, they explode. The only product is going to be a colorless, odorless liquid. Okay, so with these problems, we've got to first get organized. We've got to write down what we know that we've got. We've got what we're going to call gas 1, and we're adding it to gas 2. They're going to react, and they're forming what we can call a liquid, and I'll even add the fact that it's colorless. The first step for all of these problems is to take a look at our reference, all the properties of different chemicals that you're going to be given, and just kind of figure out what the possibilities are based on the descriptions. And then when we see what they're made out of, we can eliminate some and figure out what they must be. So let's go ahead and take a look at that. I'm going to make some space there. Two colorless gases. But the big key is that one of them is going to explode. So if we take a look here, zoom out a little bit, we've got all these different gases. We can see almost all of them are colorless, which is really not super helpful, but only one of them has a note about being explosive. So one of these gases must be H2. So we'll go ahead, and for gas 1, we'll just say, okay, that had to be H2. We've got that figured out. For the rest of them, we don't really have much other information. So for gas 2, I'm going to write down all of the other colorless gases. So not chlorine, but I'm going to do carbon monoxide, carbon dioxide, oxygen, N2, and SO2. So I'm going to do all of those. So we've got CO, we've got CO2, we've got O2, we've got N2, and SO2. It looks like a big list, but we'll figure out some way to narrow that down so we can figure out what it's got to be. Our last possible thing is our colorless liquid. So we'll take a look at our properties of liquids, and we'll see which ones are colorless. So this one's reddish brown. Oh, H2O. Water is colorless, not mercury. HCl might be a good choice, but if we look at our problem, we've got to notice that not only is it colorless, it's also an odorless liquid. So colorless and odorless kind of eliminates the HCl because we've got that odor that's described. So we'll say not HCl, but HNO3 is colorless sometimes. So we'll put H2O and HNO3. There. So we've got our different options here. Taking a look at this, we know that all of our pieces have to be on both sides of the reaction. We can't just throw away any ingredients. So if we've got something over here on this side, it's got to show up over here. That's one of our things that we can use. So we know that we've got H2 here. That's an absolute given. I'm even going to put a box around it because that shows that it is absolutely solid. That doesn't help narrow us down too much here yet. We've got hydrogen on both sides. But if we take a look, we might be able to narrow something else down. Both of these options have got oxygen in them. Our only possible products have got oxygen, so we can eliminate anything in gas 2 that doesn't have oxygen. So CO's got oxygen, CO2's got oxygen, O2 is oxygen. Oh, N2. N2 does not have oxygen, so we're going to cross this one out. And then SO2 has got oxygen, so that's a possibility too. But we did eliminate one here. N2 cannot be our gas 2. Ooh, if there's no N in gas 2, there's no N's anywhere here, then it turns out that HNO3 cannot possibly be one of our products. So that actually eliminates this other one. Okay, we're really getting somewhere. If H2O is our only product, and it's just made of H2 and whatever else there is, then we've got no carbon, and we've got no sulfur. So without carbon and sulfur, we can't have CO, or CO2, or SO2. Oh, there we go. We've got H2O and O2. So what we're going to do, once we've kind of eliminated things, we're just going to rewrite our equation. And so we know that our reaction must have been H2, that's hydrogen gas, plus O2, oxygen gas, reacting to form H2O, that's just plain old water. There we go. That's how you go through a reaction puzzle. You take it one step at a time, look at the qualities, figure out what the possibilities are, and then make sure that you've got the same pieces on both sides. Just like in our reaction in the Penny Lab, we can't make gold without getting gold from somewhere. We've got to conserve matter.